All right, hello class, Will McBurney here. Trying to just re-record the lecture from Thursday that was missed, so I'm going to just summarize what we talked about, show some of the command line stuff that we did, and I will go over command line arguments again. I'm going to do this fairly quick. It's not going to be an hour and a half lecture, but let's start by just quickly talking about why we chose Java in this class. So the reason we chose Java, one is because a lot of educational programs use Java, but a big thing worth noting is that Java is the basis of Android, and Android is not just the fastest growing operating system use in the world, but also has actually passed Windows as the most widely used operating system, partly due to just the growth of the mobile platform compared to traditional computing. But one of the big reasons that Java is used is because it works on pretty much every platform broadly. And so it is portable. You can take a program that is compiled on take a program that's compiled on a Windows machine, take that class file or jar file, put it on a Mac, and it will run all the same. You don't have to worry about cross compiling, for example. And so, whereas in, say, a language like C, you would have to potentially do cross compiling. You'd have to compile an executable that specifically works on Windows or an executable that specifically works on Mac, etc. And so, Java and all programming languages need to interact with the operating system to use processor time, memory, disk space, the monitor, whatever. It needs to interact with that. That is to say, it needs to interact with the hardware. And this is why you end up with all these, considerations for are we on a Mac, are we on a Windows machine, etc., in some other code. Java removes this need via using the Java virtual machine. So when you compile Java code, you are compiling with the JDK. So for example, I wrote this program here. Uh, IntelliJ live compiles this code every time I make changes. It recompiles on the fly. That uses the Java Development Kit, the JDK. But that's not running the code. When I run the code, I'm not using the JDK. I'm using the JVM, the Java Virtual Machine. Now, the Java Virtual Machine implements the Java runtime environment. The Java runtime environment is an abstract idea of a computing machine. It's an abstract set of instructions that Java can do. But it's abstract. We can't actually implement we can implement it. We cannot actually use the Java runtime environment. Rather, we create a JVM that implements the Java runtime environment, and this JVM is going to be unique to the operating system. So the JVM on a Windows machine is going to be different than the JVM on, say, a Mac or, say, a Linux machine. The Java virtual machine takes Java bytecode, which I'll show you in a second, and interfaces it with the hardware platform through a virtual machine. So this is done through the just-in-time compiler, which for a given JVM, whether it's Mac or Windows, takes the Java bytecode, which is then instructions defined by the Java runtime environment, and translates it into the hardware instructions, that is the processor instructions that are used at very low level of the system. And that thing, which translates the Java bytecode into the instructions inside of the JVM, is called the just-in-time compiler, the JIT. So with that, just going to briefly show you how to do this process, writing code, compiling, without an IDE. I'm going to use Notepad++. Notepad++, it does have formatting, but it doesn't compile. And what I can do is I can write public class hello world, public static void main string args, all within Notepad++, again, not an IDE, system.out.println hello world, and there's a program. Now, of course, I can't compile it here, but what I can do is save, and I saved it to my documents folder. From here, I'm going to pull up PowerShell, and I'm going to cd into my documents, and I'm going to just make sure hello world is here. I'm going to do ls hello star. That looks for any file that starts with hello. ls is for list, cd is for change directory. From there, I can compile my code with javac, javac, or java compile hello world.java. And when I've done that, I can then, if I do ls, I can find that there is a class file here. Hello world.class. There's also temp.class. I'm not going to use that right now. There's hello world.class. And this file is the file I just compiled from hello world.java. I can then run this file with java hello world, and it prints hello world. That is my program. If I want to edit this file, let's say I want better punctuation. I add a comma and an exclamation point. All I need to do is recompile and then rerun. And now look, I have the punctuation. All of that done without an IDE. The IDE does this, but it makes it simpler for you. You don't have to compile. It will compile on the fly. It will present the results to you. And that's very useful. From there, let's talk a little bit briefly about jar files. So now, actually, sorry, before I do that, let's talk about command line arguments. So command line arguments are actually in every program that has a main function, but you probably haven't used them until now. So I'm going to use the string args by saying arg0. Now here's how command line arguments work. And I'm going to navigate, actually I'm going to take this hello who.class file, and just for simplicity, I'm going to copy it into my documents folder here, which I'm doing on the other monitor so you can't see it. But now I have hello who, Java, or let's ls hello who, excuse me, hello who star. You can see there's my hello who class file. I can then run this with command line arguments hello who with things like Steve. And it will say hello Steve, or Jim, hello Jim, or Claire, hello Claire. And the idea is whatever I write in here becomes arg0. That's right here, arg0. So that's why it's saying hello who. This is useful because I don't need to modify the code. I can change what the value of certain variables are on the fly simply by changing the command line arguments. I don't need to go all the way through that. Now you can set these arguments in the IDE, because right now if I try to just run this program as is, I'm going to run hello who, I'm going to get a problem. It's going to crash because of an array out of bounds exception. And the reason for that is my args array is length 0. I haven't added any arguments. I can change that by going to run, and I can do run edit configurations, and I can add an argument like Steve. Apply, run, there you go, hello Steve. I can then go to run and edit the configurations again. I'm going to edit hello who again, and Claire, and there you go. Now it will say hello Claire. Now the thing about command line arguments is that you can always add multiple, and you add multiple by simply putting a space in between them. So I can say hello Claire, Steve, Chewbacca, whatever. Probably spelling Chewbacca wrong, but it will still only say hello to Claire. But the idea is this is arg0, this is args1, this is args2, not counting the white space I highlighted. So I could say, for example, and then I could say args1. I'm going to build. Oh, sorry, forgot a plus sign here. I'm going to build, and then I'm going to copy this hello who back into my documents folder. I'm going to overwrite what's there. And now, when I say Claire and Steve, it says hello Claire and Steve. If I add Chewbacca, it doesn't change it. I'm still not saying hi to Chewbacca. But I did that by simply adding in args1. Now remember, these are strings, so if you want to extract a number, say int x equals args2, you can't do this. What you would instead have to do is say, because args is a string, integer.parse int args2. Something like that. And then from there, Going to build. I'm going to copy this hello who class back into my documents folder again. And now I'm going to say Claire Steve 15. And it will, in this case, while I don't do anything with it, you can int x. This int x variable will be equal to 15. So that's command line arguments. You can always add more arguments, and it won't necessarily affect the program, but you always need at least as many as you expect. You can always check the length, do something like if args.length equals 0, system.out.println, hey dummy, you forgot arguments. Write a nicer message than that, but something like that can check your arguments, or maybe you do less than 3, which is currently how many I expect, something like that. So that's command line arguments. From there, I want to quickly show how to make a jar file in Eclipse. So what I'm going to do is I'm going to go to File and Project Structure. I'm going to go to Artifacts, and I'm just going to quickly create a jar file. Actually, before I do that, I need to create a new run configuration. So I'm going to create a new run configuration. I'm going to add a new one that is an application. I'm going to call it hello who no args, so no arguments. The main class is going to be hello who, and I'm going to leave no arguments. So that's the first thing I'm going to do. Now, of course, this will say, hey, dummy, you forgot arguments and crash, but that's fine for now because I'm going to add these arguments when I call on the command line, the function. From there, go to File, Project Structure, and then going to add an artifact with the plus sign, a jar from modules with dependencies, and then in temp, I'm going to select hello who as my main class. I am then going to hit OK. And then the last thing I'm going to do is include in project build. This check is to make sure that whenever I build my project, it does indeed build that jar. I'm going to hit the hammer up here to make sure it builds. When I do, you can see under artifacts, I have this temp jar. I'm going to copy this temp jar. I'm going to paste it into documents. And so when I do that, ls*.jar, you can see I have temp.jar in here, which I just added. I also have another jar, but don't worry about that one. That's from back at my days at Penn. To run this jar file, you do java and then -jar temp.jar. So you do need to include .jar here. And then I can say something like Steve, Carol, 15. Hello, Steve and Carol. It sets x to 15. Of course, then the program ends. I don't do anything with x, but you get the idea. So that's how to create a jar file, and then every time you build, it will update that jar file. You want to use that hammer just to make sure before you submit your homework, because we will grade using that jar file. With that, if there are any questions, definitely post them on Piazza, but otherwise, that covered quickly everything I covered in class, and I will see everyone. Thank you again for your patience while I got this up. Take care.